So, welcome to all on this video lecture, Digital Logic Design. In this lecture, I will cover the concept of K-map. So, myself, Dr. Neeraj Kumar Misra. In this video lecture is structured in such a way that it helpful to the student to learn the concept of K-map. I will try to cover the situation of problems faced to optimize the Boolean function. So K-map is actually used to optimize the Boolean functions. Apart, I will also try to take a complicated problems based on K-map. So these all complicated problem is helpful for the core jobs or maybe placement or some interview. So the main intention of this video lecture preparation is dedicated to UG and PG student to learn the basic concept of K-map. So without any delay, I will proceed this lecture to more discussion about the concept of K-map. So just I highlight some important points based on the Karnaugh map. So this Karnaugh map is a graphical design. This is a graphical design. So this graphical design is used to minimize the Boolean functions. Okay, so in this graphical design, there is some box, square box. So this square box is known as a cells. So if there is an n variable number of possible minterms, means in the cell there is an entry. So this entry is known as a minterm. Okay, so suppose that if we talk about the two variable K map, so the number of cells here 2 k power n means the number of n value is 2, so number of cells are 4. So like that, this is a structure of two variable K map. And if we see the three variable K map, the number of cells and the number of variable is 3. So here number of cells are 8. Okay, like that we have to form a cell. And if we go for the four variable K map, so n variable is 4. So the structure or design of four variable K map is like that. Okay, so here number of cells, if we count here, all these are the cells. Okay, this is 16 number of cells. So in this slide, I am just discuss about the two variable K map structure, three variable K map structure, and the four variable K map structure. So there is a very important point here that if we move from one cell to another cell, suppose that if we are going in this row, so here only in any row or maybe in any column, suppose that in this column in this row only one bit is change. If you go from this to here, only one bit is change, and if you go from here to here, only one bit is change. Same thing we are observing in the four variable K map. If we are seeing in this column, there is only one bit is change. Okay, so the conclusion is that if we move from one cell to the next along any row or column, one and only one variable in the minterm change. Okay, so that is the main features or main feature in the K map. Okay, now I will take some important examples. So first we will solve this question. So this question is plot the SOP Boolean expression on K map. So this Boolean function is given here. The question is, this is a SOP expression, sum of a product. Now we are going to represent this Boolean function on K map. So the first very important step is means we in this Boolean function we have to identify the number of variables. So here there is a three number of variables. Okay, A, B, and C. Okay, so here three terms. This is the first term, this is the second term, and this is the third term. So in the first term, what we are observing A bar, B bar, C bar. So the min term here 0, 0, 0. So this is the representation, means A bar in the SOP representation, A represent 1, Okay, and a bar represent 0. Okay, so this is all 0 and this is the minterm. And if we go in the second variable, second term, this is the second term, a bar bc. So this is means a bar means 0 and this is 1 1. So this is a 3. And if we go to the last term, third term, so that is abc bar, abc bar. Okay, so that is 110 and this value is 6. So fine, now we are going to represent this min term in this three variable k map. Okay, so we are looking here because these are the min term. This is the graphical design of the uh, three variable k map. So we are looking this three only, three min term 0, 3 and 6. So here if you find the min term, then in every cell you have to write 1. Okay, so I written here 1 and here I written 1 and here I written 1 because there is a 3 min term only. So 3 1 in the 3 variable k map. Okay, so this is a representation of SOP. So in the right side I given one more example. Plot the POS expression. This time I given you a product of some expression because here there is addition sign and then multiplication. So we are going to represent this function on K-map. So again, this question is solved in a two step. The first step, identify the variables. Again, we get three variables A, B, and C. And this time here, please remember this point. All the A means if the variable is A, because in the POS expression, variable A is represented by 0 and the A bar is represented by 1. Okay, so again we have to identify the number of terms in the given function. So this is the first term, this is the second term, and this is the third term, and this is the fourth term. So in first term, we are going to find out the min term. Okay, so A means 0, so all are 0. Okay, so this is the min term, decimal value. And in the second term is A plus B bar C. That means the 0 1 0. This represent 2. And if we come in the third term, that is A bar plus B plus C bar. So this value is 101 and this represent min term 5. And now we come to the last term, fourth term, A plus B plus C bar, this term. Okay, so here we get 001 and this means this min term is 1. But here one important point, this is the this all these represent min term, all these represent max term actually because this is a POS expression. So in POS expression, that max term you represent in the K map by putting 0 because in the previous example the min term, all the min term is represented by 1, but in POS expression this all max term is represented by 0 in the K map. Okay, so here how many max term? 0, 2, 5 and 11. Okay, so for max term we have to represent in the three variable K map. Okay, so this is 0 and this is 0, this is 0. Okay, and this one more 0. Okay, so this is the representation. This is the representation of means any Boolean expression, maybe SOP or maybe POS. Means there is so any Boolean expression to be represent in the K map, but the concept is something different. Okay, because here all the min term is represented by 1, but in all the max term is represented by 0 in a K map. This is the main difference. And the another difference in the SOP expression, this A value represent 1, but in the POS expression A value represent 0. Okay, so that is the difference in between SOP representation and POS representation in the K map. So I hope you understand this concept by this example. Okay, so now we come to the next cell, next slides. So here I given I given you a situation. Suppose that if I represent 1 in this K map, so how to minimize or how to find out the Boolean function? So here actually simply we have form a pairing. Okay, so for this pairing, the horizontal line means 0 1 and 1 1. This one and this one. So okay, so the opposite term is cancelled. So this is cancelled. Okay, because this is BC. So ultimately you get C. Okay, you get C. But this term 0 represent A. So that's why this is A bar C. Okay. Now the second pairing, because these two one are combined. So in this term, this vertical line A1 means represent A. So uh, in this stage 1 1 and 1 0, what is a common term? So common term is B only. Okay, so that is B. So the final expression is A bar C, because this is A bar C and this is AB. Okay, both we have to add in the SOP expression. Okay, so this is a Boolean expression uh, of this K map. So that is a grouping concept we have learned in this slide. Again, we come to the grouping concept, because sometimes this is the problems will face by many students. So suppose that the 2 1 is come in the corner. Okay, so the pairing is possible by folding of this cell. Okay, so in this two cell means 0 0 and 1 0, this term is cancelled. Okay, this term is cancelled, so that means here B bar. Okay, okay, and now we come to this value. What is this value? This value is C D bar. So ultimately the final expression is B bar, and this one C D bar. Okay, this is a Boolean function of this K map. Okay, now we come to the second this diagram on the right side, because these two ones are there. So again we have to fold. Then what is the Boolean expression we have to see now? So this one represent okay, so this is 0 0 and this is 1 0, 0 0 1 0. So this term is cancelled, so that means it is D. Okay, this is D bar. Okay, now this AB, this 1 1 represent AB. So ultimately the final expression is AB into D bar. Okay, AB into D bar. Okay, so that is a Boolean function. Now in this question, I given you minimize the following expression in this POS form. Okay, so this is the max term. This time I given you a max term. So that means this all the max term to be represented by 0. Okay, so we have to find out how many zeros in the 4 variable K map. Okay, so we have written here. Now we are going to form some pair or some quad. Okay, we have to see all the possibility. Okay, so here actually all the 4 zeros are there. So that is means that all pairing is possible. So here we get C bar D bar. Okay, so this 4 is also there, 4 0 is also there. So what is this actually? Okay, what is this actually? In the vertical line here, in the vertical line there is 0 1 and 1 1. So the opposite term is cancelled. So here we get 1. So that means this is B. And here we see what is a common term. Okay, so this is 1 1 1 0. So this term is cancelled. So that means this is C. So fine. So this term is actually represent BC. Okay, this represent BC. Okay, so this 1 0 is left. In here 1 0 is left. So what we do, we again form a 4 0. Okay, we combine all 4 0. So this represent AB. Okay, this represent AB because 1 1, this 1 1 represent AB. Okay, so ultimately this SOP, this is actually this expression in SOP format. Okay, this expression in SOP format, so we get C bar D bar, okay, plus AB, and we get BC. But here if we see the question, minimize the following expression in POS form. So here we want a POS expression. So what we do here actually, so this we get SOP expression. So the POS expression is we have to represent this SOP expression in POS format. So simply you just take a complement of this function. Okay, we have to take a complement of this function. So this is C bar D bar plus AB plus BC, and again this whole bar. Okay, so we have to simplify here because this is not a POS expression. So we know this property A plus B whole bar, that is A bar into B bar, and we know one more property AB whole bar, that is A bar plus B bar. Okay, so here we apply the first property. This is the first property and this is the second property. So if we apply the second property, that means C bar into D bar whole bar and multiply AB whole bar and multiply BC whole bar. Okay, so again this expression is not in the POS format, which so again we have to apply the second property here. Okay, so if we apply the second property, that means C double bar plus D double bar and multiply of A bar plus B bar and multiply of B bar plus C bar. Okay, so we know this property, if A is 2 times bar, that means this A come here. So that means this is C and this is D, and here there is no possibility. Okay, and again this again no possibility, so we write this expression in the same way. So the final expression, that is the expression in POS format. Okay, this expression is POS format. So what is this expression? C plus D and A bar plus B bar and multiplication of B bar plus C bar. This is the POS expression. Okay, so if you get SOP expression, then simply we are taking a complement of SOP expression and we get POS expression. Okay, so this is a concept we learned here. So again we take a one complicated problem. So this is a min term, this is all min term. So now we are going to simplify this function. So I will discuss these two method. Means this question will solve in a two different approach. So first thing, that how many terms in this expression? 1, 2, 3, 4. So what we are observing here in the first expression, so this D is missing. Okay, this D is missing. Okay, and similarly in the second expression, A is missing. Okay, A term is not there. Okay, this is your second term. And the third term, all terms are available, but again in the four terms, this D term is missing. Okay, so so this is the first step. You have to identify how many terms are missing in the given min term. Okay, so how to include the missing term? We know the property, if D plus D bar, that means 1. Okay, if we include this one in the first expression, there is no change in the expression. So because here in the first expression D is missing, that's why we are included D plus D bar. Okay, similarly in the second expression A is missing, that means we have to include A plus A bar. So in the third term, there is no term is missing. Okay, because in third term there is no term is missing, but in the fourth term the D is missing, that means we have to include D plus D bar. Okay, so after simplification, we get all the minterms. So this A bar, B bar, C bar, D represent 0001, and this triple zero 40, and this is 1010, and this is 0010, and this is 0110, and this is 1001, and the last expression is 1000. So all this min term is to be included in the K map. This is a 4 variable K map, and we have included all fours, all four, all one, and then we start the pairing or quad. So here this 4 1 are come together. That is by folding operation. Okay, from this folding because this is a corner position 1 1 and here. So if we fold like that, then 4 1 come together. So that means this expression is B bar C bar, and this 2 1 come together. That means here this we get A bar C D bar. Okay, and again these 2 1 come together. Okay, so we get if you simplify all these functions, and we get this function. So this is the one method. In this step we have to include the missing term, and we get the Boolean expression, and this Boolean expression we convert in the min term. So all these min term include in the K map by presenting a 1. Okay, but second method is very means simple. So we will go how to proceed for this question. Okay, so there is the same question, but the approach is different. So first we draw the 4 variable K map, and we know the 4 variable K map. Okay, we know this 4 variable K map. This is your AB, and this is CD. So the first expression is A bar B bar C. Okay, so that means okay, C bar. Okay, this is all 0. Okay, so this we know this one 0 0 0 1 1 1 and 1 0. This is 0 0 0 1 1 1 1 0. Okay, so A bar B bar means both are 0 0. So this is 0 0, and C is 0. That means there is a two possibility. So maybe your min term is included here and also included here. Okay, because your C is 0. So in this two position, one to be included. Okay, now we come to the second term. This second term. What is the second term? B bar C D bar. Okay, so means this time your B value is 0 and this value is 1 0. So B is 0. B is 0. That means B is 0 here and B is 0 here. Okay, and this CD bar means 1 0. That means there is a possibility to include one min term here. Okay, there is a possibility. Okay, because here your B value is 0. Okay, if the B value is 0, that means there is here position and here position. Okay, because CD bar is 1 0. Okay, now we come to the last means second last term. What is second last term? A bar B C D bar. So that represents 0 1 1 0. Okay, so 0 1. Okay, so this is 0 1 AB, and C D bar means 1 0. So that means this is min term here. Okay, now we come to the last term. The last term is A B bar C bar. So this is 1 0 0. So 1 0 means 1 0 position is this. Okay, C bar. C bar means okay, there is a two possibility in this first and second column. Okay, so we have to include one here. Okay, so the same situation here, because here this figure and this graphical design is same, so the Boolean function is also same. Okay, so I think you understand these two concept means these two concept. In first concept we have to include the missing term, and then we have to locate the min term in the K map. But in the second term is very easy, and here we get quickly we have to solve this question. Okay, one more question I given to you. Suppose that this is the Boolean function, I given to you. So we have included here all the 1, because here we get 1, 0, 2, 5, 7, 8, 10, 13, and 15. So here we form this pair, and all corner 1 form a pair. Okay, so all corner one give you the expression of b bar d bar. Okay, why we get, because here 0 0 and 1 0. So what is a 0 0 and 1 0? Okay, so this term is cancelled. That means here we get b bar, and if we look on the vertical line 0 0 1 0, that means this is CD, and this term is cancelled. We get d bar. So in the corner one, all the corner one give you the expression b bar d bar. Okay, b bar d bar, and this all square cell, all four one together give you the b d. Okay, so I think you understand this question. Now we come to the next question, that is a don't care condition. Okay, so this is a don't care condition. Okay, so here we have to locate how many min terms are here. Okay, so 0 here, and 1, and this 3, and 7, and 15. Okay, and here don't care, the don't care condition is 2, 11, and 12. So all the don't care condition is represented by x. Okay, represented by x. So this is don't care condition, and this is also don't care condition. So don't care condition is to be included to form a pair, or maybe quad. Okay, so here we form a quad. So for this all quad we get a bar, b bar, and here again we have to form a quad, because x, this don't care condition is very helpful to form a quad, all the four one, that is CD. Okay, so the final expression of this question is that is a bar, b bar plus CD. That is the answer. That is the answer. Okay, so I think you understand the don't care conditions. So finally I give you some important or interview questions that will be very helpful for core company. So the first question is, a cell with 1 in K map is not having adjacent cell. What is the name of this cell? So this cell is known as a isolated cell. Okay. Now the second question is, the output is not defined for a particular input combination. So that is known as a don't care combination. That is known as a don't care combination. Okay. Now we come to the third question. The map entered in the K map. So here we include 0 or 1, or maybe don't care, or maybe don't care. So the fourth question is, canonical SOP is known as a sum of minterm. Sum of minterms. The last question is, canonical POS is called as sum of max term. Okay, sum of max terms. So I request to the student, you just pause this video and solve, and you have to identify the answer. Okay, then you see means how much knowledge in this you have a knowledge in this K map. So some question I give you in this slide, that is a multiple choice question, and that is very also helpful for the core company. So we have to go to the first question and read the question very carefully. In the Karnaugh map, okay, dash is used for fixing the value of a minterm. Okay, so the first option is XS3, the second option is 2421, and the third option is 6-fold to 3, and the last option is cyclic. So anyone guess which answer is which option is correct? So the D option is correct. That is a cyclic code. Okay. So here we get cyclic code. Now we come to the next question. Dash is known as consequence theorem. So what is actually consequence theorem? So here first option is correct, but we have to prove that. So consequence theorem represent if is A B plus A bar C. That means this two term I is on the complicated manner, and the remaining two term is come in the product form. Okay, B and C come in the product form. That means in the consequence theorem, this product term to be neglect. Okay, if this condition is satisfied, that means the last term to be neglect. So ultimately, the final or optimized Boolean expression is AB plus A bar C. Okay, so this LHS and RHS value is equal. That means both value is correct. So I hope this video lecture is very helpful for you to understand the concept of K-map, how to locate the min-term in the K-map, and how to form a pair, and how to minimize the Boolean functions, and how to uh, fix the don't care condition in the K-map, and how to convert the SOP expression into POS expressions. So these are all concepts we have learned in this video lecture. So thank you very much to all.